Welcome to the next lecture. In previous lecture, we started our discussion with power system 2, that is power system analysis. We clearly discussed the list of topics which we are covered under PS2, namely per unit system, symmetrical components and sequence networks, fault analysis, stability analysis, load flow analysis. And later we defined what is single line diagram and what is an impedance diagram. And we took an example and by which we have drawn impedance diagram in per unit form and in absolute form. And later we concluded that impedance diagram in absolute form is really a complex one. The reason is, when you are doing the analysis using impedance diagram in absolute form, there is a discontinuity in KVL equations. So that's why analysis becomes very complex. But when it comes to the per unit form, there is no discontinuity in KVL equations. So that's why analysis becomes very simple. That's why it might be fault analysis or stability analysis or load flow analysis generally carried out using per unit form when compared to what? Absolute form. That means finally the point is per unit system is very simple compared to absolute system. Okay. So that is why our first topic in power system 2 is per unit system. First we will define what is per unit value. Later we will see what are the important things about per unit system. So first I will define the per unit value. Per unit value is defined as actual value of the quantity to the base value of the quantity. That means it is a ratio between actual value of the quantity to the base value of the quantity. Now simply actual value divided with base value will give, actual value divided with base value will give a per unit value. Okay, if you divide the actual value with base value, we get per unit value. Now, the next important formula in per unit system is percentage value. Clear? What is percentage value? If you multiply per unit value with 100, we get percentage value. If I multiply per unit value with 100, we get percentage value. Or indirectly, per unit value can also define as percentage value divided with 100. So this is also very important formula. The reason is, sir, when we are dealing with the problems on per unit system, sometimes the impedances of the generator, transformers and transmission lines are given in percentage form. For example, let's say the synchronous impedance of 11 kV 100 MVA generator. The rating of the machine is 11 kV 100 MVA is 10%. So that is given like this. So the synchronous impedance of 11 kV 100 MVA generator is given as what? 10%. Now tell me what is its per unit value? So ZS in per unit equal to what? ZS in percentage divided with 100. So that means 10 by 100, which is 0.1 per unit. So because we are going to solve everything in per unit form. So that's why even if the percentage value given, no need to confuse. Let's divide the percentage quantity with 100 so that you will get what? Per unit value. Okay. So that's why this relation is very important. Okay. Again I am saying, don't confuse by seeing percentage quantities. If percentage quantity is given, divide with 100 so that you will get what? Per unit value. Now we will see the first important thing about per unit system. Simply note number 1. Sir, the actual value and base value having same unit. So that's why per unit value is unitless. Now this is the first important thing about per unit system. So the point is clear. Per unit value unitless. No units for per unit value. Because actual value and base value having same units. Now that is the first important thing about per unit system. Let me write here. Actual value and base value having same units. So per unit value is unitless. So per unit value is unitless. For better understanding this, let's say actual voltage of a network is 100 volts. For example, at a distribution network, actual voltage is recorded as 100 volts. The base voltage is, let's say, 200 volts. The base voltage, for example, I consider as 200 volts. Now tell me what is V per unit? V actual by V base. Nothing but 100 volts divided with what? 200 volts. Volts get cancelled. So this number does not have any units. Okay. So 100 divided with 200, what I get? 0.5 per unit. So simply you say per unit. That itself is saying it don't have any units. So again I am saying, sir, the per unit value is unitless. Now coming to the second important thing about per unit system, that is note number 2. Sir, actual value is always unique, but per unit value is not unique, because the per unit value is going to change based on the base value what you are selected. For better understanding, okay, actual voltage is 100 volts. I selected the base is 200 volts. That is why 100 divided with 200 we got 0.5. Let's say if you are selected the base is 100 volts, then what is the per unit value? 1 per unit. But actual voltage, that is not going to change. The actual voltage what you are getting, what is getting to your house will not change, unless otherwise some disturbances happen in the network. But the per unit voltage in your house will change based on what is the base value you are selected. Maybe you are selected the base voltage is 230 volts. Maybe I selected the base voltage is 400 volts. So you get different answer and I get different answer. Okay. So that's why the point is clear here. Per unit value is not unique. It is going to change based on the base value selection. But actual values are always unique. Let me write here. Actual value is always unique. Per unit value is not unique, because per unit value is going to change based on base value. Per unit value will change based on base value. For better understanding of note number 2, I will take another example. Let's consider this pen, sir. The actual length of this pen is, let's take 4 centimeters. Sir, today it is 4 centimeter, actual length I am talking. Tomorrow, does it become 8 centimeters? No. Today it's 4 centimeter. Tomorrow also what? 4 centimeter. Okay. The actual length of this pen will not change. Today I am holding this. Tomorrow maybe Mr. Shankar sir will hold this. But the actual length will not change. Okay. Let's consider the base length. Okay. So for me the base length is 10 centimeter. So actual length is 4 centimeter. For me the base length is 10 centimeter. What is the per unit length? 4 centimeter by 10 centimeter. 0.4 per unit. Tomorrow Mr. Shankar came. Since he is a short man, he took base length is 5 centimeter only. Then what is the per unit length of this pen? 4 by 5, which is 0.8 per unit. For him it is 0.8 per unit. For me it is 0.4 per unit. But what about the actual length? Remains same. But per unit length is got changed. So that's why I am saying, sir, clearly speaking, the per unit value is not at all unique. It is going to change based on the base value selection. That's why you should be very careful while selecting the base quantities. Okay, we will discuss how to select the base quantities, no need to worry about that. But please accept a point here, the per unit value is not unique, because the per unit value will change based on the base value selection. Okay, but what about actual value? It is always unique. Okay, I will consider another example if you want. Let's take a resistance. The value of this resistance is 2 ohms. Today 2 ohms, tomorrow also 2 ohms. Because I told you already, actual value is a designed value which is not going to change. So, whose value is 2 ohms here. Let's say I applied a 100 volts across this 2 ohm resistance. Now the current flowing through this circuit is what now? 100 volts by 2 ohms is 50 amperes. Okay, if you are not going to disturb the network, if you are not disturbing the network, the current is always 50 amperes. Okay, for example, I asked you to calculate the per unit current. Okay, maybe I took the base quantity as 100 ampere. Okay. Now tell me what is the per unit length? Actual current by, sorry, per unit current, actual current by base current. Actual current is 50, the base current is what? 100. We get 0.5 per unit. Okay. Maybe the another person who is solving this network has to, the base current is 200 ampere. Then what is the per unit current now? Actual current by base current. Again, actual value will not change because I am not disturbing the network. So actual current is what now? 50 only, but base current is what? 200. How much I got? 0.25 per unit. So the per unit value will change based on the base value selection. Here 100, here 200. That's why per unit value got changed. That's why the point is clear again. Actual value is unique, but the per unit value is not unique. Per unit value will change based on the base value selection. Now coming to note number 3. So note number 3 talks about how to select the base quantities if base value is not given in the problem. So if base value is given in the problem, you have to follow that. You don't need to select any other base. You don't have a right to select your own base because base value is already given in the problem. Okay. So if base value is given in the problem, I don't need to worry. I am very happy. Suppose if base value is not given, then how to select a base value? Sir, the base value is selected based on rating of the machine. That means rating of the machine is considered as default base if the base value is not given. Okay, if base value is not mentioned in the problem, the rating of the machine is considered as default base. Let me write first, later we will see an example. If base value is not given, then rating of the equipment is considered as default base. If base value is not given now, then rating of the equipment we generally considered as default base. For understanding this, the receiving end voltage of a 400 kV transmission line is 300 kV. The receiving end voltage of a 400 kV transmission line is 300 kV. Calculate VR in per unit. That means calculate the receiving end voltage in per unit is asking. Okay, tell me what is the actual voltage here, receiving end 300 kV. What is the base voltage he has given? Not given in the problem. Since base voltage is not given, let's take rating of the machine. Since it is a 400 kV transmission line, the voltage rating of the transmission line is 400 kV. So that is why it is the default base. So that's why what is VR per unit? 300 kV is actual voltage. Base voltage is what? 400 kV. So how much you get? 0.75 per unit. Okay? 0.75 per unit is the answer. Clear? Now same problem if the question is given like this. Have a look. Calculate VR in per unit by considering 500 kV as base. Is clearly mentioned considering 500 kV as base. Now I don't need to take the rating because the base value given in the problem. If base value not given, then only you need to take what? Rating of the machine as base. Since the base value given in the problem, let's follow that. Okay. Now tell me what is VR per unit? VR per unit is 300 by 500, that is 0.6 per unit. For example, if you took 400 kV, then we got what? 0.75 per unit. But that is the correct answer in this case? No. The correct answer in this case is what? 0.6 per unit. Because he has mentioned the base voltage. That's why you have to follow that. Okay? Clear? But if the base voltage or base is not given, consider the rating of the machine as default base. 90 to 95% of the problems, the base parameters are not given. If base value not given means by default base is rating of the machine. Rating of the machine only, default base if the base is not given. Now coming to note number 4. Sir, the per unit value, generally people will think that it is always less than 1. Now strictly speaking, per unit value may be less than 1, may be greater than 1, may be equal to 1. Don't assume that the per unit value is always less than 1. Don't restrict the per unit value to less than 1. No, that's not correct. It may be greater than 1 also, it may be less than 1 also, it may be equal to 1 also. For better understanding of this, I will consider an example here. Okay? Similar example, sir. A 400 kV transmission line, the receiving end voltage is 500 kV. This is under no load. So, practical example, sir. A 400 kV transmission line, the receiving end voltage under no load is what? 500 kV given. Is that correct or not? Yes, it might be correct. Why? Because due to Ferranti effect, the receiving end voltage is definitely greater than rated value under no load. Clear? Now, the receiving end voltage is, let's say, 300 kV under full load. This is under full load. Yes, this is also a valid thing because due to voltage drop in the line, heavy voltage drop in the line, maybe under full load the receiving end voltage become 300 kV. Now, the receiving end voltage is, let's say, 400 kV. This is also under full load, but with compensation. Full load with compensation, the receiving end voltage is what now? 400 kV. Okay. Now the question is, calculate VR in per unit for different cases. That means for all cases we need to calculate the VR in per unit. Now tell me, to solve this problem, does he mention anything about the base quantities? He has not given a base quantity. Just check. He has not given any base quantities. So what is the default base for us? Yes, rating of the element. See, rating of the transmission line is 400 kV. So that means, what is the base voltage here to solve this problem? 400 kV. Tell me, what is VR under no load? VR under no load is what? In per unit form I am writing, sir. Actual by base. What is actual? 500. And what is base? 400. And the answer is 1.25 per unit. Clear? Now tell me, what is VR under full load? Under full load. VR under full load is 300 kV. Okay. But what is the base? 400 kV. So which we get 0.75 per unit. Now tell me, what is VR with compensation? With compensation under full load is 400. What is the base? 400. 400 by 400, 1 per unit. Now, practically you notice here, what happened? Sir, the per unit value, I said equal to 1. Yes, it is possible with compensation. Now, less than 1 without compensation and greater than 1 under no load. So, that's why, sir, per unit value may be greater than 1, may be less than 1, may be equal to 1. That depends on the conditions of the network. Okay, clear? For example, under full load, what is the current flowing through the line? 1 per unit. Because full load means what? Rated current only flowing. Rated current means that is a base current. Correct or not? Actual current and base currents are same when you are talking about rated load or full load. So that's why, what is the current per unit? 1 per unit. But what is the current flowing through the line during fault? It is almost 10 times the full load current. If you talk in terms of per unit system, 10 per unit. So that's why per unit value may be greater than 1 also possible. Okay, clear? Don't say that it may be slightly greater than 1. It may be 10 per unit, it may be 20 per unit, it may be even what? 30 per unit. Because the example is magnetic inrush currents in the transformer is approximately the maximum value of magnetic inrush current may be 30 times the rated current. That means it is 30 per unit. Nothing wrong to define like that. That's why, sir, don't think that the per unit value is always less than 1. It may be greater than 1. It may be equal to 1 also. Now we will see note number 5. Sir, base values having only magnitudes. There is no phase angle for base quantities. That means base values are only magnitudes. No phase angle for base quantities. For example, let's say the actual voltage is 200 at an angle 30 degrees. Yes, that is possible. 200 at an angle 30 degrees volts. Now what I am saying, the base voltage means, if I write the base voltage something like this, 500 at an angle 45 degrees, this is blunder, because the base means it having only magnitude. It might be voltage, it might be impedance, it might be power, whatever it may be. Base means it has only magnitude, no phase angle. So what I can write here, V base is what? 500 volts. This is correct. Okay. Tell me what is the phase angle of this? No phase angle. Okay, if you want to say 0 degrees. Okay. But simply speaking, there is no phase angle for base quantities. Actual quantities may have a phase angle, but base quantities never have a phase angle. They just have only magnitude. Now let's check what is V per unit. What is V per unit? V actual by V base. So what is V actual? 200 at an angle 30 degrees. What is V base? 500. So what I get now? 0.4 at an angle 30 degrees. This is in what? Per unit. Now just notice one thing here. The actual quantity or actual voltage phase angle is 30 degrees. Per unit voltage phase angle also what? 30 degrees. Definitely. Why? Because you are dividing this with a magnitude. Correct or not? You are dividing this with a magnitude of 500. So phase angles will not change. Okay, straightforward, simple maths. So that's why the point is clear. The actual quantity phase angle and per unit quantity phase angle are always same. That means actual value phase angle and per unit value phase angle are always same, because base quantities are representing only magnitude. The base values don't have any phase angle. Base values having only magnitude. That's why actual value phase angle and per unit value phase angle are always same. Actual value and per unit value having same phase angle, because base values having only magnitude, indirectly no phase angle for base quantities. Since there is no phase angle for base values, so that's why actual value and per unit value having same phase angle. Now we will see note number 6. So note number 6 talks about mathematical operations on per unit system and what? Percentage system. Sir, when you are doing mathematical operation, you should be very careful. If you add two per unit numbers, you will get what? Again a per unit number. That's why mathematical operation directly on per unit number is possible. Similarly, if you add a 2 percentage number, the resultant is again what? A percentage number. Similarly, subtraction. If you subtract 2 per unit number, the resultant is again what? A per unit number. If you subtract 2 percentage number, the resultant is again what? A percentage number. But when it comes to the multiplication and division, you should be very careful. I can do the multiplication with per unit numbers. If I multiply 2 per unit numbers, the resultant is again a per unit number. But if I multiply 2 per unit number, the resultant is not percentage number. That's why don't apply the multiplication and division on percentage number. That means if I divide per unit numbers, the resultant is again a per unit number. But if you divide 2 percentage numbers, the resultant is not a percentage number. Okay, that's why finally the point is clear. What I want to say in note number 6 is, when you are doing a mathematical operations, that means multiplication, division, even addition and subtraction also, do it with per unit system. Okay, but if you want finally the percentage values, once I got the per unit value, I will multiply with what? 100. That means when you are dealing with per unit system, or when you are dealing with multiplication, division, addition and subtraction, do it in per unit form. If you want percentage values, after getting the per unit value, you just multiply with 100. Finally, you will get percentage value. Okay? Clear? Now, finally, the conclusion is multiplication and division is not valid for percentage quantities, but valid for per unit quantities. To understand this, I will consider a simple example here. Let's take a resistance of 5 ohms and the current flowing through the resistance is 10 ampere. The voltage across the resistance we can calculate. Okay. Now the question is, what is V per unit? What is V per unit and percentage V by considering Z base equal to 10 ohms and I base equal to 100 ampere. Z base equal to 10 ohms and I base equal to what? 100 ampere. We need to define what is V per unit and what is V percentage. Okay. First we will go with the fundamental approach to calculate percentage V and per unit V. Then later we will see multiplication and what? Division with per unit and what? Percentage, and finally we can conclude whether the multiplication and division is valid for per unit or not and percentage or not. Okay. Now let's see first of all what is V base now. I can write V base equal to I base into Z base, nothing wrong. Okay. So 10 into 100, sorry 10 into 100, yeah. So which is 1000 volts, that is V base. But what about V actual? So voltage across the resistor equal to current into resistance, simple Ohm's law. 10 into 5, directly I am writing sir 50 volts. Okay. Now from this, what is V per unit? V per unit equal to V actual by V base. What is V actual? V actual is 50 and V base is what? 1000. Clear? Now V per unit equal to 0.05 per unit. This is the correct answer. And what is percentage V? Let's multiply per unit with 100. V per unit multiplied with 100 is what? V percentage. Can you please tell me what is that? 0.05 into 100. Okay. If you multiply 0.05 with 100, I get 5%. Okay. That is the percentage V. And per unit V is 0.05. Percentage V is what? 5%. Fine. Now we will go with another approach. We know that Z base and I base. Tell me what is R per unit? R per unit is what? R actual by what? Z base. R actual is 5, Z base is what? 10. So what I get? 0.5 per unit. Indirectly, how much percentage? 50%. R is 0.5 per unit, nothing but what? 50%. Otherwise, I will write percentage R equal to what? 50%. Clear? Now similarly, what is I per unit? I per unit is how much? I actual is 10 ampere. Okay. I base is 100 ampere. 10 by 100, which is 0.1 per unit. So I per unit is 0.1 here. Okay. Clear? Now let's see what is percentage I. Now the percentage I is nothing but 0.1 into 100. 0.1 into 100 means what? That is again 10%. If I multiply 0.1 with 100, I will get percentage value. Per unit value is 0.5. Percentage value means per unit value multiply with 100. So that is 10%. Now let's see what is V per unit. So what I am saying, I per unit and R per unit if I multiply, because we know that V equal to IR. V per unit equal to I per unit into R per unit. I am saying it is valid. If it is really valid means this V per unit should be what? 0.05. Whether we are getting that or not, we need to check. Okay, what is I per unit? I per unit 0.5. Sorry, I per unit is 0.1. What is R per unit? 0.5. So what I get now? 0.05 per unit. Check. What I got? 0.05. Here also 0.05. That means, is this valid or not valid? 100% valid. Now check with percentage numbers. Suppose if you write percentage V equal to percentage I into percentage R. Percentage I multiplied with what? Percentage R. Tell me what is percentage I you got? 10. And percentage R you got 50. Okay. 10 into 50. How much it is? 500 percentage. Tell me, is it 500 percentage? Tell me what is the percentage V? 5 percentage. But what you got? 500 percentage. That means, is this formula is valid? That means, can I multiply two percentage number? The resultant is percentage number? No. So that's why finally the point is, when you are doing multiplication and division, don't do it with what? Percentage numbers. Do it with what? Per unit numbers. Okay. Now simple point what I can say here. Ohm's law is not valid with percentage system, but it is valid with what? Per unit system. Ohm's law means what? Multiplication and division. V equal to I into R. Multiplication. I equal to V by R. Division. So Ohm's law is nothing but you are doing multiplication and division. So that's why Ohm's law is not valid for what? Percentage system, but valid for what? Per unit system. That's why to avoid the confusion, simply follow my instruction. It might be multiplication, division, addition or subtraction. Do it with what? Per unit quantities. If you want the result as percentage means, after getting per unit, multiply with 100, you will get what? Percentage number. So that's about the 6 important notes on per unit system. Okay, let me recall all the 6 notes again. The first note, what we discuss? Actual value, base value having same unit. So per unit value is what? Unitless. Next, actual value is always unique. Per unit value is what? Not unique. Because per unit value will change based on what? Base value selection. That is the note number 2. Next, note number 3. The rating of the element is considered as what? Default base. If the base value is not given in the problem. If base value given in the problem, no confusion, directly you take that. If base value is not given in the problem, rating of the element is considered as default base. That is our note number 3. Note number 4. Per unit value may be less than 1, may be greater than 1, may be equal to 1. Don't think that per unit value is always less than 1. Greater than 1 also possible. That depends on what? The actual conditions of the power system. Next, note number 5. Sir, when you are selecting the base quantities, you should be very careful. Base quantities always having magnitudes only. Base quantities are magnitudes only. Base quantities never having phase angles. They just have magnitude. That's why actual value phase angle, per unit value phase angle are always same. Now finally, note number 6. What we discussed? Multiplication and division is not valid for percentage system, but valid for per unit system. Okay, addition and subtraction valid for both percentage and per unit system, but multiplication and division are not valid for percentage system. Now simply speaking, Ohm's law is not valid for percentage system, but valid for per unit system. Now we will see per unit analysis of single phase system. Sir, it might be a single phase system or 3-phase system. There are 4 variables we need to define the base values. What are the 4 variables here? There are basically 4 variables we need to assign the base quantities. So the 4 variables are S base, I base, V base and what? Z base. But careful sir, S, I, V, Z, these are the base quantities. They are just magnitudes only. I am not writing mod S, but by default they are what? Magnitudes. That means S, I, V and Z, they represents magnitudes only. That means S is the volt ampere base, I is the current base, V is the voltage base and Z is the impedance base. It might be single phase system, it might be 3-phase system. These are the 4 quantities we need to define the base values. But if it is a 3-phase system, now there is a small change. That is, when you are talking about the current base, there exists a line current base and phase current base. We know the relation depending on star connection or delta connection. If it is a star connection, line current equal to phase current, line current base equal to phase current base. Okay, and similarly, voltage base means there exists line voltage base and phase voltage base. We know that line voltage equal to root 3 times the phase voltage. That's why line voltage base equal to root 3 times the phase voltage base. Phase angles will not come. We know that in case of star connection, line voltage leads the phase voltage by 30 degrees. But when you are dealing the phase quantities, when you are dealing the base quantities, there is no concept of that phase angle. Line voltage base equal to root 3 times the phase voltage base. That's it. Anyway, we are going to discuss all these things clearly when we come across per unit analysis of 3-phase system. But what is the difference between 3-phase system and single phase system? That is what my point here. The point is, there exists a line voltage base and line current base. There exists a phase voltage base and phase current base in case of 3-phase system. But in case of single phase system, there is no concept of line here, because we are dealing with what? Per phase only. Only phase quantities are there. No concept of line for single phase system. So please notice this. Anyway, so these are the 4 quantities, or these are the 4 parameters we need to assign the base values. Okay, clear? These are the 4 parameters I need to assign what? Base values. But careful, while assigning the base values, the relation should not disturb. What is the relation here? S equal to, we know that, V into I. This is the relation. Okay, you must select S, V, I such that this relation must be satisfied. And also, Z equal to what? V by I. Z equal to V by I. We know that Z impedance equal to voltage by current. This relation and this relation should satisfy. Accordingly, you need to select what? Base quantities. For example, I selected S base equal to 100, V base equal to, let's say, 20 volts, S base equal to 100 volt ampere, and I base equal to, let's say, 10, and Z base equal to, let's say, 5. Is it valid? No, it's not valid. Just check. If I multiply V and I should get S. What is V and I multiplication? 200. But what you have selected? S, 100. And what is V by I? Should be Z. Okay, V by I equal to what now? 20 by 10, that is 2. But what you have selected? 5. It's not correct. That is why what my point is, to avoid the confusion, select 2 variables as base quantities. That means select 2 variables first as base quantities. The remaining 2 variables you need to calculate. For example, I am selecting V and I can calculate what? S and Z. Okay, let's see. V and I you are selected as 20 volts and 10 ampere. That is a base voltage and what? Base current. I can calculate S and Z. What is S now? 20 into 10. That is 200 volt ampere. What is Z? 20 by 10. That is 2 ohms. Now this is correct now. So finally, what my point is, out of 4 variables, you must select the base values for 2 variables. The remaining 2 variables base values we can calculate by using what? Already selected values. But the question comes into mind that which 2 variables I need to select? Whether I need to select S and I, or I and VB, or V and Z, which is better? Sir, better is always S and V. Any reason? Yes, there exists a reason. Sir, if you remember, we discussed one point. The default base is rating of the equipment. Correct or not? Rating of the equipment is considered as default base. But if you take any electrical equipment, there are 2 ratings are by default given. For example, if it is a generator, simply what he will say in the nameplate, it is 11 kV 100 MVA generator. It's 11 kV 100 MVA generator. That means which 2 ratings are readily available for me? Voltage rating is readily available. And what? Apparent power rating. That means volt ampere rating is readily available for me. Voltage rating and volt ampere ratings are readily available for me. And we know that if base is not given in the problem, I need to select the rating of the equipment is the default base. Which 2 ratings are available for me? Voltage and what? Apparent power. That is why, careful, when we are defining or when we are assigning the base quantities, always known base is what? S base and V base from the rating of the machine. What is the unknown base? I base and what? Z base. That I can calculate using this simple relations. That's what I am writing here. What is the known base here? known base directly. What? S base and what? V base. From where? From rating of electrical equipment. From the rating of electrical equipment, these two are readily available. S base and V base are what? Known. Now tell me which two variables are unknown now? So better to say unknown base. Tell me what is unknown base now? Yeah, remaining two, I base and Z base. I base, Z base are unknown. Don't worry, we can calculate them. Tell me how to calculate I base and Z base. Very simple. Using this relation, S base equal to V base into I base. What is I base? I base equal to S base by V base. Simple. Then, what is Z base? Z base is V base by I base. Correct or not? Okay, I need to write Z base in terms of known. V base and S base is known. But anyway, what is I base? S base by V base. So what I can write now? V base whole square by S base. I'm just substituting I base equal to S base by V base. S base by V base. V base into V base square. And in the denominator, S base. Clear? So that's how we can calculate the unknown parameters. So S and V from the rating, I and Z from using this formulas, we can define the base quantities. Okay. Now once you define the base quantities, the next important thing is what is per unit voltage. So I can write the first formula, per unit voltage, otherwise V per unit. Tell me what is V per unit? V actual by V base. Because we defined what is V base, what is I base, and what is Z base and what is S base. So V per unit equal to V actual by V base. Correct or not? Now tell me what is I per unit? Simply I actual by I base. I actual by I base is I per unit. Okay. Now what is Z per unit? Z per unit is nothing but Z actual by Z base. Okay. See, impedance actual means, strictly speaking, it is a complex number. For example, if it is a RL load, sir, RL load, shall I write RA plus JXA, resistance actual plus J times the reactance actual. Now, what is Z per unit, sir? ZA by Z base now. Z per unit, I am writing once again, ZA by Z base. So, RA plus J times the XA by what? Z base. So, what I can write now here, RA by Z base plus J times XA by Z base. So, from this, R per unit plus J times what? X per unit. Correct or not? So, R actual by Z base is R per unit, X actual by Z base is X per unit. So, from this, what is R per unit, sir? R per unit is nothing but R actual by Z base. X per unit is nothing but X actual by Z base. Sir, again, I want to avoid one confusion here, sir. Many people will think that resistance per unit equal to resistance actual by resistance base. Reactance per unit equal to reactance actual by reactance base. Strictly speaking, there is no existence of resistance base and reactance base. That is blunder. Why? Because if you define resistance base and what? Reactance base, the next thing what you define, okay, resistance plus J times the reactance is Z base. That is blunder. Why? It will violate one rule. What is the rule? Z base means it should have only magnitude. But if you write like this, it has a magnitude as well as what? A phase angle. So that's why you cannot define like this. That means R base will not exist. X base will not exist. Only it is the Z base which will exist. That's why don't define R per unit is R actual by R base. Don't define X per unit is X actual by X base. R per unit is nothing but R actual by Z base. X per unit is nothing but X actual by Z base. Because if you define R base and X base, then Z base having magnitude and phase angle. That is blunder. There is no phase angle for base quantities. So that's why So only Z base is valid. R base and X basis is what? Not valid. Similarly, we will define the complex power in per unit form. See, the complex power S in per unit form is S actual by S base. Okay, but S actual means what? It is P plus JQ by what? S base. Correct or not? I can write this PA by S base plus J times QA by S base. So that means PA per unit or P per unit better than Q per unit. Clear? So S per unit equal to what? S actual by S base. S is a complex number. PA plus J times the QA by S base. But S is not a complex number. Careful. It's volt ampere. Okay, apparent power, not the complex power. Base is representing apparent power. Because apparent power don't have any phase angle. But complex power having a phase angle. Careful about this. Anyway, S base, no phase angle, only magnitude, maybe 100 MVA, 200 MVA, something like that. Anyway, so PA by S base plus J times QA by S base I can write. PA by S base is P per unit, QA by S base is Q per unit. So that means what I can write here is P per unit equal to PA by S base and Q per unit equal to QA by what? S base. That means active power per unit and reactive power per unit. Don't confuse. So finally what my point here, just like what we defined for R per unit and X per unit, I can define here. So there is no existence of P base. Active power base will never exist. Similarly, reactive power base also will not exist. Only there exists what? S base. Okay? Clear? P base, Q base will never exist. Only there exists what? S base. So that's why you should be very, very careful with what? So S base and what? Z base. So again I am saying P base not exist. Q base not exist. R base not exist. X base, reactance base not exist. So what exists? S base will exist. Okay. Now what exists here? Z base will exist. Okay. So that's about the per unit analysis of single phase system. Now we will consider an example for better understanding of per unit analysis of single phase system. A 200 volts 1 kVA single phase transmission line is delivering 1 kilowatt power at 0.8 power factor lagging. That means the rating of the line is what? 200 volts 1 kVA and the line is delivering how much active power? 1 kilowatt. Kilowatt, the units of active power. At what power factor lagging? 0.8 PF lagging. The series impedance of the line is what? 10 plus J, 15 ohms. What is asking? Calculate the per unit values of active and reactive powers. Calculate the per unit resistance and per unit reactance. That means we need to calculate here what? P per unit, Q per unit. For that we need to define what? S base. Now we need to calculate again R per unit and what? X per unit. To calculate them, we need to define what? Z base first. Okay, clear? And now let's see how to define the base quantities here. Does he mention anything about base? No, nothing is given. That's why what is the default base you need to consider? Rating. Okay, I can select V base is 200. V base is what? 200 volts. Then S base is what? 1 kVA, nothing but 1000 volt ampere. So that we don't have any problem with units. So 1 kVA, nothing but what? 1000 volt ampere. That is the rating of the line. So rating of the line I consider as default base. Now we require S base and Z base. What is the formula for Z base? Z base formula we know. V base square by S base. What is V base? 200 square by what is S base? 1000. Clear? 200 square by 1000, which is nothing but what? 40 ohms. 40 ohms is the Z base. Now what is given, sir? Sir, it is given that the line is delivering an active power of 1 kilowatt at 0.8 power factor lagging. P equal to what? 1 kilowatt, nothing but 1000 watts at what? 0.8 PF lag. So P actually is 1000. Sir, we know the relation QA equal to PA tan phi. That means reactive power equal to active power multiplied with tan phi. Sir, strictly speaking, power factor is nothing but what? Cos phi. What is cos phi value given in the problem? 0.8. If that is the case, what is sin phi? 0.6. Cos phi is 0.8 means sin phi is 0.6. Otherwise, you can calculate pi. Cos inverse 0.8, that is 36.86 degrees. Sin 36.86 degrees is 0.6 we get. Okay. Anyway, what is tan phi? Tan phi equal to sin phi by cos phi. Sin phi is 0.6, cos phi is 0.8. We get 0.75. That means what is QA now? PA multiplied with tan phi. PA is 1000. Tan phi is 0.75. We get 750 volt ampere reactive. Where is the units? Clear? Now let's see what is P per unit. Sir, P per unit equal to P actual by S base. What is P actual? 1000. What is S base? Again 1000. So 1 per unit. Now what is Q per unit? Q actual by S base. Q actual by S base. What is Q actual given? Q actual is 750, S base is 1000. So we get 0.75 per unit. Now I can also write here S per unit equal to what? P per unit plus J times Q per unit. So 1 plus J 0.75, that is also valid one. Clear? Now the next important thing is, so he has mentioned Z actual, the series impedance of the line Z actual is given 10 plus J 15. But what is asking to calculate? What is R per unit and X per unit is asking. Okay, let's see. R actually is what? 10 ohms. X actually is what now here? 15 ohms. Real part is resistance, imaginary part is reactance. Okay. Now what is R per unit? R actual by Z base. R actual is 10. Z base is what? 40. So this is 0.25 per unit. Now similarly, what is X per unit? X actual by Z base. X actual is 15. Then Z base is 40. So nothing but 0.375 per unit. So primarily Z per unit is what now? R per unit plus J times X per unit. Clear? 0.25 plus J 0.375. Finally, so we calculated P per unit is 1, Q per unit is 0.75, R per unit is 0.25 and X per unit is 0.375. That is how we need to solve. Now we will see per unit analysis of single phase transformer. I will consider a single phase transformer here which has a primary winding and secondary winding. We already discussed the smaller diameter circle indicates LV winding, larger diameter circle indicates HV winding. Let's say primary voltage rating is V1, secondary voltage rating is V2. Then apparent power rating or volt ampere rating or kVA rating or MVA rating, whatever it may be, that is S. If that is the case, I can calculate what is I1 and what is I2. Clear? And we can define the transformation ratio, sir. Transformation ratio is what? K. We know that N2 by N1, that also written as V2 by V1, that also written as I1 by I2. Okay, I1 by I2. But careful that the transformation ratio, whatever we define for actual quantities, also valid for what? Base quantities. But the only difference is actual quantities may have a phase angle, but base quantities will never have what? A phase angle. That means only magnitudes. So what my point is, K equal to, I can define V2 base by V1 base. Nothing wrong to say I1 base by what? I2 base. Now this is always valid. So just like actual, okay, for base quantities also the transformation ratio whatever you define is valid. Okay, but the primary is operating at different voltage, secondary also operating at different voltage. That means the K is not equal to 1. Correct or not? That's why there exists a primary voltage base and secondary voltage base. Primary current base and secondary current base. Primary volt ampere base and secondary volt ampere base, they are same. Why the primary volt ampere base and secondary volt ampere base are same? Sir, it is a transformer, constant power device. Volt ampere rating in the primary, volt ampere rating in the secondary is same. Volt ampere rating is nothing but S base. That's why the point is, there is no concept like S1 base and S2 base. It is just S base, or indirectly S1 base equal to S2 base, that is equal to S base. But primary voltage base and secondary voltage base are different. And primary current base and secondary current base are different. And primary impedance base and secondary impedance base also different. Now let's see, primary side we will define the base quantities. Tell me what is the base quantities on primary side? S base, V1 base, I1 base and what? Z1 base. Clear? So what I can write now? I base equal to S base by, sorry, I1 base equal to, I1 base equal to S base by V1 base. Clear? Now what about Z base? V1 base by what? I1 base. Nothing wrong to say V1 base whole square by S base. That's what? Z1 base. I'm sorry, it is Z1 base. Okay? So Z1 base is V1 base by I1 base. So V1 base square by S base we can write. Why? Because I1 base is what? S base by V1 base. If I substitute that, I will get V1 base whole square by S base. Now that's about the primary side. Now what about for secondary side? Secondary side also we can define same thing. Secondary side I can write S base. Okay? Same. Here and here the values are same. Yeah. Then V2 base. Then I2 base. Then Z2 base. I am directly writing the I2 base equal to S base by V2 base. Similarly, Z2 base equal to V2 base whole square by S base. Directly written. V2 base by I2 base, nothing but V2 base whole square by S base. But tell me what is the relation between Z1 base and Z2 base, I2 base and I1 base, and V1 base and V2 base? Sir, simple relation, sir. We know that V2 base equal to K times the V1 base. This is always valid. Similarly, I2 base equal to I1 base by K. From here I am writing that. I2 base equal to I1 base by K. V2 base equal to K times the V1 base. Okay. Now what about Z2 base and Z1 base? Yeah. Z2 base equal to Z1 base into K square. Okay. Otherwise, what is Z2 base? V2 base by V1 base. Sorry, V2 base by I2 base now. Right. Let's substitute what is V2 base? K times the V1 base. Correct or not? What is I2 base? I1 base divided with K. So what I can write now? K square times V1 base by I1 base. Correct or not? What is V1 base by I1 base? Just now we defined. V1 base by I1 base is nothing but what? Z1 base. So what I can write? K square times Z1 base. Now finally the relation is that Z2 base equal to K square times Z1 base. And similarly Z1 base equal to Z2 base by K1 square. Now that's about the relation between base quantities in primary and what? Secondary side. So we define what are the primary base quantities, secondary base quantities, and what is the relationship between them with what? K. K is the transformation ratio that is not equal to 1. Clear? Now we will define what is the per unit voltage, per unit current in the primary and secondary side. And then we will define what is the per unit impedance and what is the per unit impedance in the primary and per unit impedance in the secondary. Apart from that, we need to see what is the impedance referred to primary, impedance referred to secondary in per unit form. Okay. Now first we will define current. Primary side, sir. What is I1 per unit? I1 per unit is nothing but what? I1 actual divided with I1 base. Correct or not? Similarly, what is I2 per unit? I2 per unit is nothing but I2 actual by what? I2 base. But one thing, sir, what is I2? I2, have a look, sir. I2 equal to, we can write from here I1 by K. I2 equal to I1 by K. Now similarly, what is I2 base? I1 base by K. So from this, what I get? I1 by I1 base. What is I1 by I1 base? Nothing but I1 per unit. So we can say I2 per unit equal to what? I1 per unit. So that means this is very, very important relation, sir. The per unit value of primary current and the per unit value of secondary current for a single phase transformer are always same. The per unit value of primary current, per unit value of secondary current are always same. Now we will see voltage relations. Sir, I can write V1 per unit is equal to what? V1 actual by V1 base. Similarly, V2 per unit is equal to what? V2 actual by V2 base. But if you remember, we know that V2 equal to what? K times the V1. Correct or not? K times the V1. But what is the V2 base? V2 base is what? K times the V1 base. So from this, what I can get? K get cancelled. V1 by V1 base is nothing but what? V1 per unit. That means for a single phase transformer, the voltage in the primary in per unit form equal to the voltage in the secondary in per unit form. This is also very, very, very important relation. That means the primary voltage in per unit, secondary voltage in per unit are always same. Now we will see the impedances. But careful, when it comes to a transformer, there exist 4 different impedances. Z1, careful sir, this is primary impedance. Primary impedance. Don't call it as impedance referred to primary. It is just a primary impedance. That's it. What is Z2? This is secondary impedance. Secondary impedance. Okay. Z2 means it's a secondary impedance. What is Z01? Which is impedance referred to primary. Don't call it as primary impedance. Which is impedance referred to what? Primary side. So what is the formula for Z01, sir? Z01 equal to Z1 plus Z2 by K square. You know already this. Okay. Now Z02. Z02 means what? Which is the impedance referred to what? Secondary. Impedance referred to secondary. Clear? Impedance referred to secondary. What is the Z02? Z2 plus Z1 into K square. Z2 plus what? Z1 into K square. So similarly we can define Z1 per unit, Z2 per unit, Z01 per unit and what? Z02 per unit. Now we will see what is Z1 per unit. Sir, Z1 per unit means what? The primary impedance by Z1 base. Simple. That's about Z1 per unit. Now, what is Z2 per unit? Z2 by Z2 base. Z2 by Z2 base is what? Z2 per unit. Now, what is Z01 per unit? Z01 actual by what? Z1 base. Okay. Let me rewrite this Z01. What? Z1 plus Z2 by K square. Correct or not? Z01 is Z1 plus Z2 by K square. So, divide with Z1 base. Correct or not? Now, just have a look here. I can write Z1 by Z1 base. That is the first term. Second term is what? Z2 by K square into Z1 base. But please, careful about this. What is K square into Z1 base? We know that this is a Z2 base. K square into Z1 base is what? Z2 base. Now finally, what is Z01 per unit? Z1 by Z1 base, Z2 by Z2 base, nothing but Z1 per unit plus what? Z2 per unit. Clear? That's what Z01 per unit. Z1 per unit plus Z2 per unit. Okay? So, there are two formulas I given. This is the one formula, this is another formula. Okay? Suppose in the problem, primary impedance, secondary impedance in per unit is given. You just add them so that we get what? Z01 per unit. For example, in the problem, Z01 actually is given. You divide with Z1 base, you will get what? Z01 per unit. Okay? Depending on the requirement, you can proceed. Anyway, what is Z02 per unit? Z02 per unit. Z02 per unit is Z02 by Z2 base. That is equal to Z2 plus Z1 into K square by Z2 base. I can write Z2 by Z2 base plus Z1 divided with Z2 base by K square. Have a look. Z1 K square by Z2 base. I can also write Z1 by Z2 base by K square. Okay. But what is this term? Z1 base. The term represents what? Z1 base. Okay. Now have a look, sir, what I get here. I get here Z2 per unit and this is what? Z1 per unit. So that means, tell me Z01 per unit and Z02 per unit. Check, both are same or not same? Yes, they are same. Z1 per unit, Z2 per unit. So finally, what my point? In case of a transformer, the impedance referred to primary in per unit, the impedance referred to secondary in per unit are always same. So for a transformer, impedance referred to primary, impedance referred to secondary in per unit are always same. Not only impedance, current also in per unit form in the primary and secondary are same, and voltage also in per unit form primary and secondary are same. Okay, clear? That means in case of a transformer, always V1 per unit equal to what? V2 per unit is the final conclusion, sir. And I1 per unit equal to what? I2 per unit. And Z01 per unit equal to what? Z02 per unit. Careful, sir. Don't say primary impedance. Impedance referred to primary in per unit, impedance referred to secondary in per unit are always same for a transformer. But what is the relation between Z1 and Z2? We can't define. Don't say Z1 per unit equal to Z2 per unit. That is not valid. That may be different. Okay. But impedance referred to primary, impedance referred to secondary are always same. And one more thing, sir. What is the transformation ratio in actual quantities? V2 by V1. This is an actual. But in per unit quantities, what is the transformation ratio? V2 per unit by V1 per unit. This is equal to 1. But this is not equal to 1. Okay. Clear? Understand? That is the reason why V2 per unit equal to V1 per unit, I1 per unit equal to I2 per unit, and Z01 per unit equal to what? Z02 per unit. Okay. If you have any doubt, so K in per unit form equal to 1. What is I2 per unit? You can write I1 per unit divided with K per unit. I2 per unit equal to I1 per unit by K per unit. Since K equal to 1, what I get? I2 per unit equal to I1 per unit. I2 per unit equal to I1 per unit because K per unit is 1. And we know that Z01 per unit equal to what? Z02 per unit by what? K per unit square. Actually K square, but I am not dealing with actual numbers, per unit number. Z01 per unit equal to Z02 per unit divided with K per unit square. But since K equal to 1, Z01 per unit equal to Z02 per unit. This is the another way to answer. Okay, anyway, we are already given a proof. This is the one way to answer why I2 per unit equal to I1 per unit, why Z01 per unit equal to Z02 per unit. Because K per unit is always 1. That means K is the transformation ratio in per unit form. That means K we are calculating by dividing secondary voltage in per unit with what? Primary voltage in per unit. But V2 per unit and V1 per unit are same. That's why K in per unit form is always 1. That's about the analysis of single phase transformer. Now we will see this example. The impedance referred to primary of a 200 volts by 400 volts 1 kVA single phase transformer is 20 ohms. Calculate the per unit impedance of a transformer referred to primary and referred to secondary. Sir, per unit impedance of a transformer referred to primary and referred to secondary are always same. Okay. So if you calculate Z01 per unit, the same answer for what? Z02 per unit also. But anyway, we will calculate both. And finally, we will prove that Z01 per unit and Z02 per unit are what? Same. Okay. Anyway, so first we will solve for primary side. Let's see on primary side, what is S base 1000 volt ampere, correct or not? 1 kVA. Okay. What is V1 base? Check. 200 volts. Rating of the machine is default base. Don't forget that. Tell me what is Z1 base? Z1 base is V1 base whole square by S base. Okay. V1 base means 200 square by 1000, which is what? 40 ohms. 200 square by 1000 is 40 ohms. That is the Z1 base. Tell me what is given in the problem. Z1 is given or Z01 is given? He has not given primary impedance of a transformer. He has given the impedance referred to primary. Impedance referred to primary. That means Z01 is given. What is Z01 actual? 20 ohms. Can you please tell me what is Z01 per unit? Z01 actual, that is 20 by Z1 base, that is 40. 20 by 40, which is what? 0.5 per unit. Similarly, what is Z02 per unit? Because impedance referred to primary, impedance referred to secondary in per unit form are what? Same. You should get this. Anyway, we will solve. Okay. Let's see on secondary side. On secondary side, what is S base? Same. 1000 volt ampere. What is V2 base? So V2 base 400 volts. 400 volts. Now similarly, what is Z2 base? V2 base square by S base, nothing but 400 square by S base is 1000, so which is 160 ohms. Okay, clear? That is Z2 base. But what is Z02 in ohms? We need to calculate that first. See, we know that Z02 actual is equal to Z01 actual into what? K square. But what is K? V2 by V1. V2 400, V1 is 200. So 400 by 200, that is 2. So let's calculate Z02. Z01 into K square. Z01 is what? 20 ohms. So 20 into 2 square. Clear? So 2 square means 4, 4 into 20, 80 ohms. Now let's calculate Z02 per unit. Z02 per unit means Z02 actual by Z2 base. Z02 actual is 40 ohms, Z2 base is 80 ohms. 40 by 80 is what? 0.5 per unit. Okay, clear? So finally, the point is what? Z01 per unit 0.5, even Z02 per unit also 0.5. It's just a mathematical proof for what we defined already. Okay, so impedance referred to primary and impedance referred to secondary in per unit are always same. Now that is the beauty of per unit system. Now we will see this example. The impedance referred to primary of a 100 volts by 300 volts 1 kVA single phase transformer is 0.1 per unit. That means what is given here? Z01 in per unit form is given. How much? 0.1. Calculate the actual value of impedance referred to secondary. What is asking? Z02 ohms is asking. But we know that Z02 per unit equal to what? Z01 per unit, which is equal to what? 0.1. Clear? So what is Z2 base? If I know the Z2 base, I will multiply Z02 with Z2 base, I will get the actual impedance referred to secondary. So what is S base? 1000 volt ampere. What is V2 base? 300 volts. Now tell me, what is Z2 base? V2 base whole square by S base. So what is V2 base now? 300 square by S base is what? 1000. Clear? So 300 square by 1000, which is nothing but what? 90 ohms. 90 ohms. Now what is Z02 actual? Z02 in ohms equal to what? Z02 in per unit multiplied with what? Z2 base. That means actual value equal to per unit value into base value. We just defined per unit value is actual by base. Actual value is what? Per unit value into base value. Correct or not? Now let's see what I get. Z02 per unit 0.1, Z2 base 90. So we get here 9 ohms. So that is the impedance of a transformer referred to secondary in ohms. Now we'll see this example. The primary and secondary impedances of a single phase 200 volts by 400 volts 1 kVA transformer are 0.1 plus J 0.4 per unit, 0.4 plus J 1.6 per unit respectively. Calculate the per unit impedance of transformer referred to primary and referred to secondary. Calculate the actual impedance of transformer referred to primary and referred to secondary. That is the question. But what is given, sir? Sir, he has not given Z01 and Z02. What is given? The primary and secondary impedances Z1 and Z2 given. But careful, Z1 in per unit form is given. What is Z1 in per unit form? 0.1 plus J 0.4 per unit. And what is Z2 in per unit form? 0.4 plus J 1.6. That is also in per unit. Now, have a look, sir. First question, sir. We know that Z01 per unit and Z02 per unit are same. That is equal to what? Z1 per unit plus Z2 per unit. So, what I get now? I need to add Z1 and Z2. 0.1 plus 0.5 plus 0.4 plus 1.6, that is 2. So, 0.5 plus J 2 per unit. That is the impedance referred to primary and impedance referred to secondary. So, coming to the second question. Sir, in the second question, what is asking? Calculate the actual impedance of transformer referred to primary and referred to secondary. Okay. So, for that, you need to define S base. S base is what? Default base to calculate this per unit system is rating of the transformer. What is S base? S base is 1000 volt ampere and V1 base is 200 and V2 base is 400. So, Z1 base is V1 base square by S base, nothing but 200 square by 1000. 200 square by 1000 means 40 ohms. Now Z2 base is V2 base whole square by S base. Clear? Otherwise, Z1 base into K square. K is what? 4. Correct? Sorry, K is 2. 400 by 200. Whatever the way you can calculate, you will get the same answer. 400 square by 1000, which is 160 ohms. Okay? Even if you calculate Z2 base equal to Z1 base into K square, K is 2, Z1 base is 40, 2 square means 4 into 40, 160. Both the way you get the same answer. Anyway, what is Z01 actual? Z01 per unit into Z1 base. So, what is Z01 per unit? 0.5 plus J2 times what? 40. So, what I get? 40 into 0.5, 20 plus 40 into 2, 80. 20 plus J 80 ohms. Okay. So, 20 plus J 80 ohms is what? Z01 in ohms, actual impedance. Now, Z02 actual equal to Z02 per unit multiplied with Z2 base. What is Z02 per unit? Same as Z01 per unit, 0.5 plus J2 multiplied with 160. So, what I get now? 160 into 0.5, that is 80 plus 160 into 2, that is 320. So, 80 plus J times the 320 ohms. Clear? Now, we will see this example. A single phase load is drawing 50 at an angle minus 30 degree ampere current from a 200 volts 100 ampere mains. Calculate per unit current drawn by the load, per unit voltage of the load, per unit impedance of the load, the per unit active and reactive power drawn by the load. Is clearly mentioned, sir. See, there is a single phase load, no doubt it is what? An RL load. Why? The current is what? At an angle minus 30 degrees. Okay. So load having some impedance, the current drawn by the load is what? 50 at an angle minus 30 degrees. Nothing wrong to say this is the actual current. What is the actual voltage? That is not mentioned. So no doubt you need to take the main voltage. Main supply is what? VA, that is 200 at an angle 0 degrees. Clear? First we will calculate all actual parameters. Later we will see the base quantities. If you know the voltage and current, I can calculate the impedance. Z equal to what? Directly VA by IA. So 200 at an angle 0 degrees by 50 at an angle minus 30 degrees. So what I get now? 200 by 50 is 4 at an angle 30 degrees. 4 at an angle 30 degrees ohms. That is what? The Z actual. Okay. What is the complex power? SA. VA into IA. That means VA into IA conjugate. That means 200 into 50 at an angle plus 30 degrees. Clear? 50 at an angle plus 30 degrees. So if I calculate this, the complex power is at an angle 30 degrees. 10,000 at an angle 30 degrees. Okay, that is S actual. Clear? Now we need to see what is the base quantities. Clear? So what is V base? Rating of the mains only considered as default base. V base is 200 volts. I base is what? 100 ampere. If that is the case, what is Z base? V base by I base, nothing wrong. 200 by 100, that is 2 ohms. Clear? Then what is S base? S base is what? V base into I base. Magnitude only, no concept of conjugate. Okay. So 200 into 1000. So 200 into 1000 means what? 20,000 volt ampere. Okay. Here also volt ampere. So in this real part is active power, imaginary part is reactive power. Now coming to the per unit quantities. First question. Calculate the per unit current. See, what is I per unit? I actual by I base. See, what is the actual current? Actual current is 50 at an angle minus 30. Base current is 100. Base current 100. So what I get now? 0.5 at an angle minus 30 degrees per unit. Now what is V per unit? V actual by V base. What is V actual by V base? V actual is 200. V base also what? 200. So 200 at an angle 0 degrees by 200. We get 1 at an angle 0 degrees. Now what is Z per unit? Z actual by Z base. Otherwise V per unit by I per unit also Z per unit. V per unit is 1, Z per unit is 0.5 at an angle minus 30, sorry, V per unit is 1 at an angle 0, I per unit is 0.5 at an angle minus 30. That means 1 by 0.5 at an angle minus 30 will be what? 2 at an angle plus 30. Correct or not? Otherwise, we can solve using the formulas here. Okay, let's have a look. Z per unit is Z actual by Z base. What is Z actual? Z actual 4 at an angle 30 degrees. What is Z base? 2 ohms, that's it, Z base. So 4 by 2, 2 at an angle 30 degrees, careful, per unit. Okay, I think if you solve from V per unit by I per unit also you will get same answer. Let's check that. Okay, that's about third question. Now fourth question. Fourth question again, sir. S per unit is V per unit into I per unit conjugate. You can do that. Otherwise S actual by S base. S per unit. S actual by S base. What is S actual? 10,000 at an angle 30 degrees divided with S base. S base is 20,000. So what I get now? 10,000 by 20,000, that is 0.5 at an angle 30 degrees volt ampere. Okay, sorry, per unit, right? Yeah. In this real part is active power per unit, imaginary part is reactive power per unit. What is PA per unit? 0.5 cos 30. Okay, what is QA per unit? P per unit, Q per unit. Okay, 0.5 sin 30. Clear? 0.5 cos 30, 0.5 sin 30. Cos 30 is root 3 by 2. Sin 30 is what? 1 by 2. You can substitute, you can get the final answer, sir. So this is how we need to proceed. So with this I am concluding this lecture. In the next lecture we will see per unit analysis of three-phase system.